Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone. Today we have with us Poornima Peiris, who is a student at the Nanotechnology and Bioengineering Department at Harvard University. Hi Poornima, welcome to Real Sci Nano.
Hi, thank you for giving me this opportunity. It's great to be here. Thanks.
Wonderful. Let's get started. Could you explain to us how did you end up in your current research field?
Yeah, of course. So I just always had a fascination for things in the nanoscale. I was like wondering like how we can manipulate things at such a small atomic level.
Mm-hmm.
And I also realized, there was, like I told you before, there was not many women in that field as well. So I just always thought as a sort of a challenge, to be included in that field. And so that's how and I took actually did a little bit of research in a clean room. And I found that really interesting, even though like we had to work with like things like neurotoxins, and which was kind of dangerous, but at the same time, I just found the research very like intriguing and really challenging. And then I ended up taking a course, a bio devices course, with one of my professors, and he was a really good lecturer. And then I approached him and I said, I might be interested in doing some work, if you have, opportunity for a student to work with you. So then I ended up, working with his group, and that's how I sort of ended up doing this research that I'm doing right now. Yeah.
Okay, that's quite a journey. Interesting. You mentioned a bunch of keywords which we picked up on. So, in order to understand exactly where your research fits, could you tell us about how and where does your current research fit in this big picture of materials or nanoscience?
Yeah, so I would say our group is called the Nanophotonics group. So so I would say there's a lot of physics involved, and especially looking at like optical properties. So you could say, I guess, we're working specifically the nano optics section, how we can, manipulate light with different objects and kind of analyze those properties at the nanoscale.
Okay. Yeah, that to some extent we understand that. Okay.
I think it looks better in pictures. Like you can see like the spectrum. Then people are like, oh, color is okay. We understand. Yeah, but when you're explaining, it sounds very
So there
kind
would
of
be a lot of
mundane.
pictures.
Yeah.
There would be pictures in your week on Twitter.
Yeah, I actually went to this exhibit yesterday. It was about the Polaroid project. And they actually it was pretty interesting where they kind of go through the whole how the Polaroid came about and what kind of invention things that they use for the daily to end up where they are now.
Okay, that sounds interesting. Let's do another podcast on that.
Yeah. No, I just found it interesting because I'm also working with like a multispectral camera and like some of the physics that they were using, sort of similar. Yeah.
Okay, different
Yeah.
question there.
Yeah.
Yeah. Okay. All right. Do you have a favorite experiment or research project that you have worked on, or is a project that you're super proud of? And could you pick one and explain it to us in super simple words?
Super simple words. That sounds okay. So, well, currently I'm actually kind of new to the field. So, specifically focusing on nano wise, I don't have much to add because, like I said, like my research is kind of, I can't reveal too much about going to specific because of the funding and the publishing reasons, which is kind of unfortunate. Which I always thought like, detrimental to science. Specifically, everybody's trying to compete with what paper they should publish first before the other group and stuff. But like I said, it's basically like trying to analyze a, multispectral sensor
Mhm.
um, that's equipped with special like nanowires
Mhm.
to image certain objects that's not usually visible in the RGB spectral range.
Mhm.
Yeah.
Okay.
But other than that, another small project I was working was in a, I guess, in the clean room for
Mhm.
nanoscale. So building a sort of device for EEG type of device
Okay.
for like toddlers, actually little children. So that kind of required a lot of like precision and
Right.
a lot of hands-on things. Yeah.
Right. Well, both the projects sound super interesting. Now
Yeah.
let's go a bit away from the sciences and more in the research experience. Still in the sciences, but away from the actual
Mm.
research, more around it. I hope so far you have had an amazing experience being a researcher. If you had to pick three wishes, if you had three wishes to improve your research experience, what would you ask for? And I'm not
Oh.
promising anything. Okay, so
Seriously.
sorry.
um, yeah, I would say I think the number one would be like unlimited access to a mentor,
Mm-hmm.
24/7. I know they have a life. And so replying directly right away to emails and giving you specific points like what you want would be
Mm-hmm.
number one, I guess. And then I guess the second one would be being able to like instantly digest a research paper slash any slash any like program or thing or technique that they want you to learn so that you can move on to like the next step in your research. I think that would be like the next best thing because like that you don't have to spend all this time like trying to see
Review.
what this is. Yeah, exactly, review and trying to understand and digest everything. And I guess the third one would be, I guess, being able to like read minds, specifically, specifically within my lab group, because
Okay.
sometimes like you don't know what they exactly mean. Like they
Mhm.
could say something and then mean something else. So
Right.
so then there would be like no confusion between you and your lab partner, so you understand. Yeah, I think those are the top three that I have right now. That would be helpful.
Okay, very fair wishes. I wish I could grant them, and
Oh,
in some parallel universe, I am granting them.
thank you.
Some sort of, I don't
I,
know.
I feel the energy.
Okay,
Yeah.
whew. There you go. All right. So, what are you looking forward to in the next 3 months?
um, Publishing a paper. No, I was kidding.
Yay!
Yeah, I think that's what my PI is hoping, but let's see. But
Yeah.
I'm looking forward to moving with the next steps with this project that I'm working on, the
Mhm.
especially the mining project, because it's like just like starting right now. So we
Okay.
are trying to because we're working with the international group as well. So
Okay.
we're trying to collaborate with them because they provide the funding, obviously.
Right.
So we have to keep producing data so they can see what we're doing.
Right.
So trying to make more headway with that, I think, and also maybe having like some happy accidental discoveries because we did have one like recently, and it kind of like made everything sort of go smoother,
Mm-hmm.
and everybody in the lab is kind of in like happy mood. So I would say that as well. Yeah,
Ah, okay.
yeah.
Well, that's I hope I wish to hear in 3 months down the line or 6 months down the line from Poornima, like, hey, there was this discovery
Yeah. I'll be on
accidentally.
the news, right?
Yeah, you'll be on the news. Okay, so she said it here first on the podcast.
Yeah.
Okay, cool. So before we wrap up, could you explore a bit into the challenges which are faced by the field of materials or nanoscience in general so that everyone understands?
Um, yeah, I think one of the key things in science in general, I think also would be like funding. I think it's still a major issue because specifically a specialized area, I think also doesn't get that much funding because as opposed to like cancer research or something like that.
Hmm.
I think that in a way is sort of kind of difficult for some of the researchers that they always have to keep like producing either really good results and like a really great paper that everybody's like, oh my god, this is like groundbreaking and things like that.
Mm-hmm.
But also I think in terms of like operating, I guess instrumentation wise is
Mm-hmm.
also kind of a challenge because you're looking at things in a certain scale that you can't see with like the visible eye and things, and that requires special kind of instrumentation. I think that's very actually like very expensive. Like I think recently we were looking at some equipment that we needed for the lab, and that cost about like 4,500. Even though it was like a very small thing, and this was just on eBay, and it's not even from like
The vendor.
yeah. So it was like just a used product, even so. That is another challenge, I think. Um, and I could say I think in terms of I guess manipulating materials is also a big question mark in nanomaterials, and how we can and how these devices specifically like impact humans slash animals in terms of the safety profile. I think that's a lot of things to explore there. Yeah.
Mm-hmm. Okay. Well, I hope the community, the science community, is going in the right direction in solving these problems, and I hope some of the funding agencies are listening in
Yeah,
as well,
yeah, I hope
because
so too.
because
Crossing
we
my
get,
fingers.
yeah, we cross our fingers because I get this question or I get this wish or this challenge quite often so far on the podcast, like, hey, the
Mhm.
funding, there should be a different way of doing it or something. Okay, cool. Thank you very much, Poornima, for speaking with us. It was a lot of fun.
Yeah,
And
thank you for having me.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.